Good morning, class. In our last class, we have started the chapter organic chemistry, and we are discussing about the important terms related with it. Today, we are going to discuss about classification of organic compounds, how we can classify organic compounds into different types. Then we'll discuss about homologous series, or we also call homologs, and functional group. What is a functional group in organic compound? So, classification of organic compounds. So, organic compounds mainly can be classified first in two types. One is aliphatic or open chain compounds. The structure will be like this, where we have got a carbon carbon chain. It can be a straight chain or it can be a branched one. Then we have got a second type of organic compound that we call cyclic or closed chain compounds. In this, we have got a cyclic structure like this, where it will form a closed figure. Okay, so these are the two main types of organic compounds. Again, aliphatic or open chain compounds can be classified in two types: saturated and unsaturated hydrocarbons, we called. In saturated hydrocarbons, we have got a very important compound called alkenes, which is also known as paraffins. Paraffins have got the general formula CnH2n plus 2, where n is an integer which ranges from 1, 2, 3, 4, it goes on. So alkane, the example of alkane we have taken when we have taken the example of alkane in this way. In alkanes, we have got a carbon hydrogen and we have got a carbon carbon single bond. In unsaturated hydrocarbon, we have got a double bond and triple bond. In this, we have got unsaturated is further classified into alkenes and alkynes. Alkenes, the general formula is CnH2n. Example, ethene or ethylene we call, where we have got carbon carbon double bond. And the second type, we have got alkynes, where we have got the molecular formula CnH2n minus 2, and the structure is like this, having a carbon carbon triple bond. So this is about the classification of open chain compounds. Now we'll see the classification of closed chain. So in cyclic or closed chain compounds, it is basically first classified in two types: homocyclic and heterocyclic. Homocyclic means where in the closed ring, where all the atoms should be same, that means it will be of the same carbon only. Whereas in case of heterocyclic, we'll have one atom different from the carbon, say for example nitrogen, oxygen. Okay, this we call heterocyclic, this compound we call pyridine, and this is called furan. Okay, so in homocyclic is further classified in two types: alicyclic and aromatic. Alicyclic is a closed figure like this, and aromatic having an alternate double bond. This we commonly call it as a benzene. Okay, this we compound we call it a benzene. So this is the classification of organic compounds. Okay, this is the classification of organic compounds. Next, homologous series. Homologous series may be defined as a group of compounds in which the various members have similar chemical properties, can be represented by the same general formula, possess the same functional group, then differ by CS2 unit. So all these are the characteristic properties of homologous series, we can say. They have got the same chemical properties, they represent the same general molecular formula, and they have the same functional group, and they will only differ by CS2 unit. So to understand this, we'll take an example. Say for example, alkanes, which have got the general formula CnH2n plus 2. So with n equals to 1, we have got the formula CH4, that is methane. With 2, we have got C2H6 ethane, C3H8 for propane, C4H10 for butane. Now if you see this one by one, methane and ethane, now if you see the difference between this, if you subtract this CH4 from C2H6 formula, you'll get CH2, C2 minus C, and H6 minus H4, H2. So the difference will come as CS2. Again, once again, if you see the difference between these two, it will again come as CH2. If you see the difference among these, it will again come as CS2. Now if you see that each member in this alkanes differ by only CS2 unit, so this kind of compounds we can call it as a homologous series. Next, functional group, a very important term in organic compound. An atom or a group of atoms which determines the characteristic properties of all the members of the same homologous series is known as the functional group. So in a organic compound, The group which determines the characteristic properties of that compound, we call it as a functional group. For example, this is an example of an alcohol where we have got OH. This OH indicates the characteristic properties of this alcohol. So this is the functional group. Similarly, in the carboxylic acid, we have got this group C11OOH. This is a carboxylic group which is acts as a functional group, and it shows the characteristic properties of that compound. No. Now here we have got the list of the different functional groups that we have got. We have seen in this in the tabular form: structure of functional group, name, and corresponding class. Say for example, if this is X only, X can be fluorine, chlorine, bromine, iodine. Name will be halo, then it is halogen derivatives. OH, hydroxy, it is alcohol. OR, alkoxy, it's ethers. COH, formal aldehydes. This functional group we call aldehyde. CO, carbonyl, we call ketones. This just now we have seen carboxyl, carboxylic acid. COCl, acid chloride, and we call acid chlorides as well. This is an ester. This group is an ester. This is an amide, CONH2 amide group. NH2 is amino, and we corresponding class we call amines. Nitro compound. CN cyanide. NC isocyanide. So these are the important functional groups, okay, of the organic compounds. In our next classes we'll be studying about the nomenclature. There we'll again see the naming of this compound. Okay, so for the time you just remember that this functional groups have got their classes name as this one, and name we called in this form. Okay, now today's assignment number 11: give two examples of each of the following: alkenes, alicyclic compounds, aromatic and heterocyclic compounds. You need to give the examples. In the examples you need to mention its structure and its name. Okay, question number 2: define homologous series with the help of an example. And question number 3: what is a functional group? Give few examples along with their structures. So this is today's assignment. You complete it and send it in my mail.